Hello Year 11. Today we're going to look at calculating the rate of reaction at a particular point. So far we've done it over a range, what we call a mean rate of reaction. But today we're going to look at a different technique. We're going to start, as we start most lessons, with our retrieval practice. I've got an equation here. Hydrogen peroxide breaks down into water and oxygen. What are the reactants? What are the products? Then I want you to do a calculation. A piece of magnesium of mass 2 grams completely reacts with sulfuric acid in 1 minute 6 seconds. What is the rate of reaction? Another calculation. A reaction produces 78 centimetres cubed of carbon dioxide gas in 1 minute 30 seconds. What is the rate of reaction? And finally, I want you to tell me what type of bonding you'll find in sodium chloride and what type of bonding will you find in water. I want you to pause the video now, find yourself some paper if you haven't already, and start doing these questions and come back when you've done them. Okay, welcome back. Right, we're going to go through the answers now. So there is only one reactant here. It's called hydrogen peroxide. There are 2 products, water and oxygen. Right, to calculate the mean rate of reaction, we're going to divide the mass 2 grams by the time. Now we need to convert 1 minute 6 seconds to seconds only. So we're going to divide 2 by 66 and you get 0.03 grams per second. Okay, a reaction produces 78 centimetres cubed of carbon dioxide in 1 minute 30 seconds. What is the rate of reaction? Again, we need to convert the time to seconds. So it's 78 divided by 90, which gives us 0.87 centimetres cubed per second. What type of bonding would you find in sodium chloride? Well, you have a metal and a non-metal, so it's ionic. And what type would you find in water? Well, it's simple molecules, so it's simple covalent. Right, here's our success criteria for today. We need to be able to recap what we've already learned about the average rate of reaction and look at graphs to work out an average rate of reaction. And we're going to learn a new technique of calculating a rate of reaction at a particular point by drawing a tangent to a graph. Okay, when we are doing exam questions, we have to pay close attention to the wording of the question. If you're asked for the mean rate of reaction, we use one of these 2 equations, either the quantity of reactant used over time or the quantity of product formed over time. Okay, let's look at this question. A student is investigating the rate of reaction between magnesium and hydrochloric acid. So the equation is magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen. So the only way that we can actually measure this rate of reaction is by measuring the volume of hydrogen produced. So she has measured the volume of gas every 10 seconds and plotted the results on a graph like this. So we've got a rate of reaction curve. Calculate the mean rate of reaction after 10 seconds. And I'm going to show you how you would go about doing this. Okay, so I'm going to go to 20 and I'm going to go up from 20 to where the graph is. Then I'm going to go across to find out how much I've produced after 20 seconds. So I've produced 36 centimetres cubed. So I'm going to divide 36 centimetres cubed by 20. And that's going to give me 1.8 centimetres cubed per second. And that's how we work out the mean rate of reaction from a graph. Now I'm going to ask you in a minute to tackle these 5 questions and then when you have paused the video and you have done the reactions, come back and we'll go through them together. Okay, the first question asks us the rate of reaction where we're producing 15 centimeters cubed of oxygen in 6 minutes. Now we can either give our rate of reaction in centimeters cubed per minute, or we can give it in centimeters cubed per second if we convert the units. So 15 divided by 6 gives us 2.5 centimeters cubed per minute, or 15 divided by 150 gives us 0.1 centimeters cubed per second. All right, the next one, we've got 6 grams of sulfur produced in 24 seconds. So that's quite straightforward. 6 divided by 24 gives us 0.25 grams per second. Right, the next one, the reaction between calcium carbonate and hydrochloric acid, in which 0.6 grams of calcium carbonate was used up after 2.5 minutes. So what we're going to do here is you could put it in grams per minute, or you could put it in grams per second. So if you put it in grams per minute, it's 0.6 divided by 2.5 gives us 0.24 grams per minute. If you put it in seconds, it's 0.6 divided by 150 gives us 0.004 grams per second. Now the next question looks quite funny because we've got moles, but don't worry about that. It's still a measure of how much substance we've got. So we're going to divide 2.5 times 10 to the minus 3 moles of hydrogen by 10 seconds. And we get 2.5 times 10 to the minus 4 moles per second. Okay, the next one, the reaction between magnesium and hydrochloric acid, in which 1.7 grams of magnesium completely reacts in 45 seconds. So we're going to divide 1.7 by 45 seconds, and that gives us 0.038 grams per second. So hopefully you're quite confident in calculating the mean rate of reaction. And that means we've achieved our first success criteria. Okay, so we're going to try and tackle our second one now, to be able to calculate the rate of reaction at one point by drawing a tangent to the graph. Okay, again, pay close attention to the wording of exam questions. If you're asked for the rate of reaction at a certain time, draw a tangent on the curve at the specified time. A tangent is at 90 degrees to the curve. Okay, and we're going to use this equation to calculate the gradient of our tangent. So that's a tangent. That's at 90 degrees at 20 seconds. Okay, so we have to be very careful that we are drawing it at 90 degrees. So step 1, draw a tangent to the curve and read off the graph at both ends of the tangent. So we're looking at 48 centimeters cubed and 28 centimeters cubed. And at the bottom, for the time, we have got 10 seconds and 34 seconds. So we're making it into a triangle. Okay, so the gradient is a change in y over the change in x. So if I go back, the change in y is 48 minus 28. And the change in x is 34 take away 10. Okay, so we've now got 20 over 24, and we're going to calculate like we did with the mean rate of reaction. 20 divided by 24 gives us 0.833 centimeters cubed per second. Okay, so we're going to try this now yourself. Now, I know you may not have any graph paper. Okay, so you may have to just attempt to do this and guess what's actually going to happen. Right, calculate the rate of reaction at 20 and at 40. So calculate the rate of reaction at 20. Okay, so we need to get the point 20 and draw a 90-degree line to the point, then draw a tangent. Then we're going to make it into a triangle, which is going to give us our 2 different points. Okay, so the bottom of the triangle is at 14 and the top is at 22. The first point of our triangle is 10 and the second point is 30. So again, we can do our calculation. So the change in y will be 22 minus 14 and our change in x will be 30 minus 10. So there we go. 22 minus 14 gives us 8 and 30 minus 10 gives us 20. So the gradient at 20 seconds is 8 divided by 20, which is 0.40 centimeters cubed per second. Now let us look at the rate of reaction at 40. So we're going to do the same thing again. It's a little bit more difficult when it is flattening off, but we're going to draw a 90-degree line at 40, draw a tangent. We're then going to make it into a triangle. And we can get our points then. So we've got 21 as our bottom of our triangle, 28 as the top of our triangle, starts at 20 and ends at 60. I always like to make my triangle so that at least one of the sides is nice and easy to actually calculate. So the change in y is going to be 28 minus 21. The change in x is 60 minus 20. So 28 minus 21 is 7 and 60 minus 20 is 40. So our gradient is 7 over 40 and it's 0.175 centimeters cubed per second. So you can see it's a lot lower, the rate of reaction at 40. Let's try and explain this. Okay, so the rate of reaction at 20 is 0.400 centimeters cubed per second compared to 0.175 centimeters cubed per second at 40. This shows that the rate of reaction is higher at 20 seconds. We know this because there are more reactant particles available to collide and react, which creates a lot of product in a short space of time. But as the reaction progresses, there are fewer reactants, so the chances of successful collisions are much lower, causing a slower rate of reaction. Okay, so hopefully when you go back to school, you'll be able to practice the drawing of tangents. But for now, that's how we do it. All right, goodbye, Year 11.